So let's wait 5 minutes for.
Yes, I was going to ask if we are everyone in the meeting, or if not, we can.
No, we have to wait a bit.
Yeah.
So I'll wait. Let's wait a bit. Yeah.
I have planned to wait for 5 minutes, just in case we are everyone in the meeting already and we are waiting for no one. But
We always start a
it's
bit.
no problem. Yeah,
5 minutes late.
Okay.
So we'll be also streaming on YouTube in parallel. It's automatic, just for your information.
Okay. One more minute and maybe we can start. At the
Yeah, you can
beginning,
start.
at the beginning of the presentation, I'm going to present myself, a little bit about the company and so on. So if anyone joins a little bit later, it's not going to miss.
Yes, and they also some learners they watch it in replay because they are working right now.
Don't worry.
So it's recorded for information.
Yes. Yeah. So I'm going to start now. If anybody wants to see the presentation, the beginning can see later. So as you see in the
Yeah.
okay now. This conference is going to talk about digital twin, of course, but focused on the Automotive Factory. Juan, my colleague, is going to present in detail an example of a real digital twin we developed for an automotive company here in Valencia. So, as I say, Juan Antonio Párraga is my colleague. He's a senior developer and project manager. He have a lot of background on digital twins and different developments. And I'm Roberto Galeana. I'm business development and project manager. I'm engineer. I'm not expert in development. I work more in the business part of the company. Okay, but we wanted to show first this, my view or the view from this side of the business. Well, in my background, I worked for 11 years for Ford before joining Tyris.AI, and I have different roles, never as a developer, but always related to technologies and product implementation, process layout, planning, etc. So Tyris.AI as a company, we are a company which is focused on industrial artificial intelligence. We have physical doctors and data scientists and so on in the development side. And as I say, we are focused in industry. We have clients in automotive, in construction, in metal mechanic, infrastructure, and water and treatment. Where I have another example of for this sector later on. We are going to pass through it quickly. We work for several big companies and say very exigent environments. In our specialties, we have like 4 big departments. One is the predictive analytics and machine learning, With that, we have predictive quality control, intelligent detection, and in the last couple of years, we started to implement some projects with NLP component, okay, which is now is very trendy. One of our big departments is in computer vision. We are not talking much about it in this session, but we have a deep learning vision system which can help us to identify behaviors not decided, for example, in automatic stairs, or if the personal protection from the workers are not being weared properly in a construction site. All this kind of detection, which cannot be made with the classic vision, but now it's possible. Also in the side of quality. Okay, for example, we can review with a camera how is the well cord is, and then analyze depending on if it's how bubbles or not, or how it is, depending on all of this, and they identify identify if the well cord is okay or not. Digital twin and simulators, we are going to talk about this in this conference. And deep learning for vision for quality, I already commented it. What is a digital twin? I'm going to be very quick on this because you know more than me. It's a dynamic virtual representation of physical asset that evolves in real time. It's not a 3D model. For us, it's key that we have quality information source. In the case for automotive, one of these information sources are the sensors in all the plant. Juan is going to explain better, but one of the complex things is that the sensors are in very different tools or machines. It can be a robot, it can be a Titan machine, it can be a lot of things. And then the life cycle, as you already know, design, operation, and maintenance. The sector matrix, this is more on my side, have identified that depending on the sector, the clients or are more interested in one output or in one kind of output than the other. For example, in manufacturing, for example, have a project, we can see later on very quickly as well, with Picolinos, which is a saw maker company here in Spain. They were very interested in the batch optimization because depending on the material, which material are more available, which stocks or which kind of shoes are predicted to be more sell or whatever. For example, if it's summer or if it's winter of so on, which kind of show we need to prioritize to build to manufacture. Quality control and predictive maintenance. Okay, in automotive company, is very important layout optimization and flow planning because regarding the machinery, normally the predictive maintenance in automotive are separated for digital twins. It can be another source of information, but as it is, as I say, very hard environment. Normally, predictive maintenance is already in place, and the digital twins are not designed for it. It's a part of the variables you have for the digital twin, but it's not designed for it. Have layout optimization and robot coordination, which is hand to hand. Flow planning and consumption. This is, let's say, residual. It's not the main objective. And infrastructure, as you say, BIM integration and efficiency sources. In efficiency sources, we have this project in the water treatment plant here in Spain as well. We can see later on. And focusing on the automotive factory, as I say, process layout, coordination, flow planning is very important. Specific challenge, we have high density of robots and automation, different kind of robots, different kind of machinery to do this automation and so on. High complexity processes as well, and a lot of processes, high complexity and high volume of processes. Need for synchronized movement. If you stop one part of the factory in the paint shop, later on in assembly, they need to stop. So everyone is all the factory is connected. In the case from the Automotive Factory in Valencia, they have 5 plants which are independent in some way are independent, but they need to work coordinated, because if we just stop painting cars, you cannot assemble the car because they are not painted. And also for doing the product launch, as they are very complex products, the launches of a new product, of a new vehicle, is a big deal always. So before investing tens, thousands of or hundreds of thousands of millions in the plan design for building a vehicle, they want to simulate and to plan before they start all these modifications in the factory. Okay, if you do this and you don't delay the launch, for example, you will have a smooth vehicle launch, and you won't have to change any production plan or to extend any life of the previous product, or things that are not good at all. Here, sorry that it's in Spanish. I will translate, but I think for the drawings you will know what we are talking about. This is the 4 steps we follow for in fact for every kind of project, including digital twins. First, we need to have all the data from, in this case, from the line from the plant of the production vehicle, or the vehicle production plant. It could be PLCs, it could be even cameras, it could be databases, it could be, in the case of the vehicle launching, could be the processes expected for the vehicle, which are the past maintenance issues or launch or past quality issues which have affected the production. Then we have this big data core, which is for historization and pre-process all this information. Then we have our models for artificial intelligence. Depending on the project we are working on, we will need another one model or another. And then in English, the dashboard. Okay, we can set alarms, or we can show a flow chart, or okay, this is depending on the client. In another way to see it, first we have the physical asset, we have then the edge computing and ingestion, then cloud platform, and then dashboard or 3D viewer, depending on the project. Okay. This is more in detail what we were commenting before. Okay, the real value of a project when we are starting with a client talking about his product, is important to them to understand that the quality of the digital twin we can make it depends totally on the quality and the amount of information they are going to give us. If the information is not reliable, or is not representative, or is not enough, we cannot predict or to do any digital twin which will be helpful for them. Okay, because the data, all the planning, all the modification they can do, it will not be a real output. The one for the digital twin will give us, and it can be just ending a 3D model, which is what we don't know. We don't want. Sorry. Okay. One of the samples, for example, in Picolinos, which we were commenting before, we saw a 32% of increment in the produce or in the shows made, and 26% of availability of the machines. Okay, this is due to the planning that we were making in this case regarding first on the capacity of the machines, and then here it's important that the Picolinos, this company, gave us not only the sensors of the machines, but also downtimes, the reason for the downtime, for the downtime, and so on. In the other hand, we have also a model which can need to, or what it does is to predict the volume of the shows that are going to be required to be done. As I said before, depending, for example, in the time of the year, depending on the sample and the prediction they have, or if it's a new model or not. Also, one of the issues is that they need stock for the materials for doing the shoes. And then, depending on the availability of this material, also not availability only in the warehouse, but also delivery times and so on and so on. You can decide better if you can do more shoes from one kind of another, uh, taking in account all what I said before, to avoid downtimes, to avoid to need to change from one model to another at the middle of the batch, let's say, because you run out of X material or because you are very late on delivering another kind of shoe. So in this case, this digital twin is predicting this, and also they allow the client to plan this production with a digital twin, and seeing which effects are going to have in the production line. And this one, Regenera, is the one which I commented in water treatment for energy. We finished this project last year. It was funded by the European Union. In this case, again, the sources were very important because in one hand we have sensors. For example, when you treat the water, the methane, I don't know how to pronounce it, methane gas is created. This is stored, and then you can create energy with this gas. So you have a sensor which tells you which is the amount of gas you have, and with this you can calculate how much energy you can produce with it. Also, you have the prediction based on the historic data on how much gas is produced during the year, and how much you can take in account that the gas is going to be produced, and you need to to consume it, okay, before this gas need to be freed because it's too much stored. Also, we have the energy price for this decision, which is the goal of this project is to help to predict in one hand, and to in the last moment, let's say, helping the decision for this client to which energy source I need to use in every moment to be more efficient, and it's the most cheap. Energy prices, as you know, or you may know, in Spain, we have different prices along the day. This is regulated, and depending on the hour of the day and so on, the public administration calculate a price, and then if you are going to subasta, it's like public sale of energy, let's say, which are a fixed price. If you know which time is the cheaper, you know that if at 1 in the morning you need to consume energy, is the best time to take it from the public grid, and left the energy you have stored in, for example, with the gas, left for another time in the day, which the energy will be expensive. Also, we have historical weather and condition prediction and so on. One of the sources was solar energy. So, of course, it's not the same if you are in January or February and so on. It's not the same that you are in summer. So, depending on this, the model also take this in account, and take it in account for the decision. And also the process itself. We have an historic and so on, and also the client can simulate with a digital twin. If I have a peak of usage, which are the best strategy for the energy consumption. So we have both ways for the simulation. The client can simulate how much energy they are going to use, and in the other hand, we have the historic as data source to know that in some part of the day or depending on the variables, the process are ongoing, and then the energy consumption is higher or lower. Okay. After this introduction and giving my view of the thing, I'm going to leave you with Juan. Okay. I think that you will find more interesting their part, as he is going to go more for the detail of a specific digital twin, in this case for automotive sector. So Juan, if you want,
Thank you, Roberto.
you're
Let me
welcome.
share.
Awesome.
Hello there. Let me check the correct screen and share. Can you see my screen?
Yes.
Okay, cool. So thanks everyone to join to that presentation of a real use case that we implement here in Valencia. I will do a quick introduction of myself. I'm Juan Antonio Parraga, and now I'm project manager at Tyris.AI. I have a really background, but on the technical side, I was working as a developer from back or full stack, depends on the company, in several sectors like healthcare, automotive, accountability. So there is a lot of background on the technical side, but the last few years I moved to the manage on the projects. So when I came to Tyris, they say, "Hey Juan, you are going to manage a digital twin project." I say, "Okay." So the first thing that comes to my mind, what is a digital twin? So that's the going to my mind. A digital twin. That was a cool car in the past here in Spain, but after 2 years working nowadays, I know that that's not a digital twin on automotive side. So I will show you a little bit agenda of what we're going to comment on the real case. So a product vision of the project, the technology, architecture, and these different models that we implement. If there is any doubt, or please interrupt me. So I will continue with my speech. What's the customer needs and what they say at the beginning with the requirements? So that's a lot of information that they want to manage. So they would like to use properly a lot of data sources because they have several legacy applications that control the assembly plant and the other plants. They want to anticipate problems, manage. I mean, they want a single point to control everything. So there's a endless list of wishes and magic requirements that they want, but that finally occurs on that product vision, where they decide to provide them to match those requirements as a global platform for predict, control, and analyze for the intelligent utilization of production and quality process. That was the vision of the product that we want to achieve on the development side, and they can use it to manage all the requirements. In terms of the technology, as you can see, there is a bunch of technology that we use. You can be in the middle, the AI technology, but because the picture was created for AI, so they will be more important than the rest. And in some places should be the people that is still needed for the development. But for now, let's see in the future. So there is all the technology that we use, even AI technologies to improve our development, the databases, the languages, and also the structure for the cloud. So it's just not 2 or 3 things, or there is several. So that's that's the part of the architecture. As you can see, that's more or less, I mean, it's more or less is the model that we created. looks like that it's a monolithic application, true and false, because we try to split as much as we can the modules and to be impacted in case of any issue. And also you can see there is a kind of layer that we use to connect all that industrial network. As Roberto said, the PLCs, the cameras, the sensor of the car, so everything can be get it or gather that information that we transform into valid information for the different people on the plant. This is a specific case of the GCP architecture. That's the way we get the DX file. That's the CAD files to draw the backgrounds on the plant. So we rely on the GCP architecture. So we use buckets and also the PubSub to get the real-time information, and everything is on the cloud runs for the front end and the back end. So that's a small piece of the architecture inside of the GCP cloud. The next thing is the data model. As you can see, it's not only 3 tables and 2 views, it's a big model. We realize or we decide to use PostGIS and Postgres because based on what the slide said, this as powerful and robust. Also, the knowledge inside the company was more oriented at those technologies. So we decide to use it as a repository for the data, and also for the customer. There is no one construction about which one use in this case. I forget that they put the BigQuery. At least models the data that the customer achieve. They finalize on the BigQuery tables. But that's the core of the application on the sense of the geospatial situation. But other information is on the BigQuery side. Okay, that's one of the pictures is the layout side. I mean, that's the representation of the factory. In that case, that's a clean part that we call background, and that is embedded on the frame of the application. On the top, you can see that we have 5 modules that we explain later. And on the left side, there is the menu that you can do actions or configure the layout side. So that's an example of the assembly line. So you can see the operators distributed on the plant, and also the vehicles moving in real time, when they move from one station to the other. So you can focus on one part of the area because you are in charge of that, and you can configure what you want to see. In that case, I'm interested only in the operators, on the workstation, and the cars. Maybe other colleagues need to check another kind of elements, so they can configure on the left menu with the blocks that you can hide or show any information that you want. So it's completely customizable. Sorry, and that's also everything themes rely on the view. I mean, the view is a container of all the information that you want to see at that moment. You can save it, and every time you go into, you will have that view prepared. The view can be configured for myself, but also I can share with my colleagues, so that could be public or private, but everything is managed from that left menu. And that's also important that's one of the goals of in that case of the GL twins on the plant area is get the KPI. So now you see on the right side that we have a KPI, but can be multiple. So I can configure several KPIs and decide which one is the most important. So in case of they are not achieving the goal that we defined, I will get an alert about it and can be take actions on that. Also, in the right side and the left part of the chart, you will see that we are predicting what happens in the next hour. So in this case, that operator is really far of the objective, so I can prepare the rest of the team, try to avoid that prediction on, and just in case we will finally occurs or not. But you have a prediction about based on the historic information, what will happen. And also there is two other parts, that's the search and advanced search, that can be also useful for the customer, because there is a kind of use case that the people wants to know where are the black cars, or even one piece where is distributed in whole plant. They can find using those options. Search is really quick, it's just for the caption, but advanced search is able to go inside of the metadata of any element. So related to that, on the left side on the panel, you see that you can get information about the KPIs, metadata, as we say, any link related with a component, and also in the details, you get information about the element, but also you are able to remove, put in the correct position, in just in case when we import the CID file is not correct, I can move the element to the correct position, and that it will be safe, and also finally modify the DX file just in case we need to import again on AutoCAD or on other application. So that's a quick recap of the module. Besides of the features that there is interactive keys or can support any other layers, you can see they have a column based on what we finally get to the estimated time and the real time that we need to develop that part of the application, and also the roles what was involved in the team. So we have a GSI expert, 3 full stack data science for the KPIs. So it's a big team to accomplish that. And also the technology, it's a subconjunto, sorry. It's a subset of the information that we see in the first slide regarding the technology. So that's for the layout. That is a small visible part of the application. But now this we call the ugly duckling, because it's not impressive on the front side, but is where we realize all the magic for the data. So as we said at the beginning, there is a lot of source of data, but they are not talking each to another. They don't speak the same language. They have something similar, but maybe for the same piece, 3 different told or call them in different ways. So with that part of the data governance, the idea is to unify, sanitize, and all this distributed data put in only one site, and they have a common language, so I can get information across all the data. So it's created somehow in a hierarchical way, because first of all we need the source, the entities, then we relate the source with the entities, and then relationships between entities. So that's created in a hierarchical way to finally get one piece explained across all the application, and we can get more information instead of say have the things split, and also improve that process at the beginning. They forget any information, they get to download the Excel file, get into a system, trade the data. So this allow, it's not, as I said, it's not like the visual part, but it's a huge magic or work behind that. So that's again the resume, what we try to achieve, what's the goal for that model. That's also really big. We estimate around 8 months, more or less. And also it's not more related with the development side, but yes, more on the side of the data science, so that we need to change a little bit the roles of the teams. and realize a lot of technologies on the GCP like Dataplex and Dataform and BigQuery. So besides the features, the idea behind is the one model to rule them all. So that's the one that the rest of the modules are growing because they have all the information good prepared. Other module, that's alarms, that's more beautiful. We are trying to improve, but that's the landing page where you have to be focused on what's the issues that you have already opened and what's the things that you need to take care about your everyday, just in case you have any alarm in the line because there is a liquid that goes out the container, or there is a tool that needs to be repaired. So you can create this kind of alarms over all the information that we gather with the previous model. So I can get an alarm on the KPI, on a camera, or whatever system that we get information. And you can filter for the critical, knowing which one is open, and define new rules to validate things. That was a little bit less hard, not totally, but were 5 months. So, but in this case, was more related on the development side and part of the data. So we need people in charge of DBI and so on. Next module, dashboard. That's kind of marketplace. It's a place where I can create new dashboards based on a Looker template. So that technology is good because it's also for the Google. So we can link and create a new dashboard based on a templates, and you can link the data set. So it's easy to create a new dashboard over there. Also, we allow the possibility to, if you have a previous dashboard in another technology like Kafka or Air, you can link it here, and then you can use this dashboard everywhere. I can link the dashboard for elements or in an alert. So it's really useful, and also it gives you the explanation why the alarm blinks or something like that. That one, yeah, I mean, because the powerful in that side was the Looker, so we invest more time in create the templates to allow the users to create easily a new dashboard. But for the rest, as we said, it's a kind of marketplace when we can have all the dashboards that we need or use later. Almost in the finish, don't worry. Home, that's the landing page of the application. So that's where you go every morning. You can configure and customize everything here. You can create new tables, new columns, new cards inside, and you can put all the information that you want to see or you have a quick access. So in this case, that's an example of I have an alarm or a KPI of the layout or a dashboard that you use normally to get information. So most of them also are navigable. So I can navigate. So in case of the KPI was in red, so I want to know what happened there. So if I click, then the system will move to the layout side and put the correct view about this KPI, so I can investigate a little bit what was the green, what the red comes out. Same for the alerts. In case I have any alert blinking, I can go and check with the metadata related with that information. I can analyze or do actions or close it because it was a non-issue or no was a higher issue. That model, yeah, is really customizable. We invest more effort on that side. Yeah, I can do whatever I want. I mean, based on the restriction, but it's for each user can put all the information around the system on that landing page. You can access quickly onto overview. So that's what we developed for the automotive customer, and that's the conclusion that we get at the end of the project. But because it's still alive, we are improving and creating new features. But the important for the digital twin from the automotive side was the control improving, because I can see how it's going and can think how improve based on the KPIs, anticipate any problem based on that AI prediction, and understand the situation, knowing what's happened now at that moment on my plant. Everything is going well, everything is going worse or not, and also take decision based on that information. And the continuous improvement on the software technology, on the I think we can improve all that, our digital twins with big compatibility. So sometimes not all, but you can imagine you can develop it and implement. So that's what's my speech. For me, was quickly. I don't know for you. So now, if you want, we can do a question if you have, and I try to answer it. Mm, that was clear or not? No question. So everyone is awake, or